No, this isn't another present from our cousin in France. She's got something planned but won't tell us what though. This is a lot more OTC, ibuprofen tablets. Today we're going to extract and purify ibuprofen from these and also look at the molecule in some more detail because it's quite interesting. We'll also show you how tablet extractions can go wrong. Let's have a quick look at the molecule. A few interesting features. It's a propionic acid derivative, but you can also see a phenylacetic acid backbone in there as well. There's a pyrride substituted tertiary butyl group on the ring. And there's also two optical isomer possible, but we'll come onto that later. Okay, let's weigh the tablets. We've got 40 tablets here, each containing 400 milligrams of ibuprofen, so that's 16 grams in total. But the total tablet weight is 25 grams, so that's 9 grams or 36% by way of fillers and binders and other things. Technically these are known as crap and we will need to remove them. Okay, first step is our standard operating procedure. Getting there. We'll bash it a bit more so it's a bit finer. Okay, here we go. We're going to try out two different extraction processes. Firstly, we're going to see if we can get the ibuprofen to react with sodium hydroxide, forming what should hopefully be a water-soluble sodium salt. Then secondly, we're going to try an organic solvent extraction process. So we've split the crushed tablets into two batches, each containing 12.5 grams of powder. Let's deal with the first. As you remember from the structure, ibuprofen is a carboxylic acid and in its acid form it's virtually insoluble in water. But we'll see if it can dissolve in sodium hydroxide solution to form a soluble salt. Here's 3 grams of sodium hydroxide, which should be about twice as much as we need in theory to react. And here's 50 ml of cold water. First we'll make up the sodium hydroxide solution. Okay, here we go. So let's add the crushed tablets and stir it up. Here's our first sign of trouble. The solid aren't easily dissolving. In fact, it actually looks as though the mixture is starting to thicken. Tablets often contain cellulose derivatives such as hydroxymethylcellulose. In contact with water, these compounds can form thick gels, similar to the ones you get if you mix corn flour and water together. We left this mixture to stand for a little while and it became thicker over time. Here we are 15 minutes later. It looks like a paste. This is not filterable or extractable using another solvent. It's an intractable mess. We added some hydrochloric acid to the mixture to see if this would reverse the process. But it didn't. In fact, we've now successfully synthesized ibuprofen cottage cheese. Yum yum. So this method is a dead end. A nice idea in theory, but you'll find this with a lot of tablets. Water should be your last resort in terms of extraction unless they're really pure and without much crack in them. Okay, so let's try something different with the other 12.5 gram batch of our crushed tablets. Ibuprofen is highly soluble in chloroform, DCM, acetone, and a few other organic solvents. Ethanol not so much though. So let's try acetone. Here's 40 ml of dry acetone and hopefully this will be able to dissolve out the ibuprofen without swelling up the cellulose tablet binders into a gel. We'll give this a good stir for a few minutes. Looks like we've got a lot of the solid dissolving very rapidly. So we set up to filter. We wash the beaker and solids carefully with about another 20 ml of acetone. Here's our acetone filtrate containing our ibuprofen. And here's what was left over in the filter. A white strangely textured solid. The acetone was very efficient at extracting the ibuprofen, so there's nothing left in here. Okay, we're now just going to take the acetone filtrate and use a hot plate to evaporate down the solvent. While we're doing that, let's take another look at the ibuprofen molecule because there's an interesting feature that we haven't explained in any previous video. This is the concept of what's known as optical isomers. Some molecules can exist in two forms which are mirror images of each other. Like you have two hands, left and right. And this happens in a molecule where you have a carbon atom connected to 4 different groups. So look at the examples on the screen. Only in one of these do we have a carbon which has 4 different things attached to it. So let's look again at ibuprofen. Can you spot a carbon atom which has 4 different groups attached? Well, there is one, and it's here. And let's draw out the 2 mirror images so you can see that it's just like your 2 hands. There's a left-handed version and a right-handed version. Now most of the time you don't know this. In fact, the physical properties such as melting point and solubility of these 2 compounds are identical. And when they interact and react with any simple molecules which don't have mirror images, they also have exactly the same chemical properties. But there is an exception. When these compounds react with other molecules which have mirror images, the behavior can be different. Just like if you try to shake hands with someone using both your right hands together, it feels weird. The terminology used sounds a bit strange. A carbon with 4 different groups attached is called a chiral center. And the 2 versions of the molecule are known as optical isomers, or also as enantiomers. Inside the human body, the amino acids that make up your proteins mostly exist as just one of these mirror image forms. And this is why when it comes to drugs, there is often a big difference in activity between the left and right-handed forms. Sometimes you can even get drugs or molecules which have multiple chiral centers. And then it becomes even more specific. Check out tramadol for a good example. But just remember that unless they are interacting with something else which has mirror image forms, the chemical properties are the same. Okay, well, we're left with a slightly viscous liquid in the bottom of the beaker, and so we allow this to cool. Crystallization is quite slow, so we'll add a bit of ice to see if this helps it along. It's happening but slowly. So what we're going to do now is not crystallize this completely, but instead we're going to redissolve the crude ibuprofen we've got here in sodium hydroxide solution to form the sodium salt. Here's 3 grams of sodium hydroxide, and we'll dissolve this in 40 ml of water to form a clear solution. As you can see, the ibuprofen is starting to crystallize. So let's add the sodium hydroxide solution to the oily ibuprofen. The result is really very pretty. So watch and enjoy for a minute. And finally we've got the clear solution. And interestingly, this soon crystallizes itself into a quite thick mass of crystals of the sodium salt of ibuprofen. A quick blast of heat though and it redissolves, so it must have quite a sharp solubility curve in water. Okay, so now we'll add some concentrated hydrochloric acid to the solution and this should precipitate out the ibuprofen, leaving any water-soluble impurities behind in solution. Here's 10 ml of acid. And the ibuprofen has separated again as an oily liquid on the surface. With a bit of cooling this soon crystallizes, so we break up the solid and then filter off our product. We wash very thoroughly with water and then dry the product. It takes a while to dry. And here we go. Our dried final product, which is pure ibuprofen weighing 7.5 grams. This is a 94% recovery on the material in the starting tablet batch we used, so a little bit of mechanical loss but not much. We've got some very cool ideas of what we can do with this, but we need to do some rigging up and get our safety procedures down pat before we do, so stay tuned. Okay, one final note on ibuprofen extraction. You may also come across non-generic tablets which are colored and maybe look like this. Normally the coloring is on the outside only, and the center of the tablet contains a composition very similar to the one we just covered in the video. The catch though is that you really need to get rid of this outer coating before you try to do any organic extraction, otherwise it really messes things up. You can do it by hand, but it's a bit painful. We also found that soaking the tablets in a small amount of absolute ethanol worked at loosening up the outer layer, which then fell off quite easily without dissolving too much of the product. So now we've got another interesting carboxylic acid to play with. Thanks for watching and stay tuned.